The modern era was a defining point in the development of our modern world. Travel, politics, governance, society, many things flourished, but nothing had a greater explosion than science. Of science, one of the most important things to appear during this era was the creation and conceptualization of the internal combustion engine. The internal combustion engine helped connect our world, bringing people from long distances together through piston engines, rotary engines, and ultimately through jet engines.
Hello everyone, I'm Tenzin Sanda, and today I will talk to you guys about the different types of piston engines within the internal combustion engines category. So there are several different types of piston engines, and they are 4-stroke, 2-stroke, and diesel. Those are the three most common within the piston engines. So they all work a little bit differently, but they all have the same concept. Piston engines have been known to man to be one of the most effective inventions during the 20th century, and I'll talk about them today. So here we have a 4-stroke cycle engine, and for the first stroke going down, it sucks in air and fuel mixture. Second stroke, it compresses that air and fuel mixture. Third stroke, the spark plug ignites this mixture and pushes the piston down, and that's the combustion or the power stroke. And the last stroke will be going up, which will push the exhaust gases out of the outlet. So here we have a 2-stroke engine illustration, and within the 2-stroke, when the first stroke goes up, it will compress the fuel and air mixture, and the spark plug will ignite this mixture. When that happens, the combustion phase begins. When the combustion phase begins, this piston gets pushed down. When that happens, when the piston gets pushed down, this exhaust port opens up. That will allow the burned gas to escape through the exhaust. And then also at the same time, this inlet will open up, just like so. When that happens, new fuel and air will come through this and get in here, and it will be compressed once again to be burned and compressed. So here we have an illustration of a 4-stroke diesel engine. Diesel engines can be both 2-stroke or 4-stroke, and the only difference that a diesel and a regular 4-stroke has is that the first initial intake in a diesel is only air, not fuel and air. So when that air gets compressed, the temperature will rise, and a fuel injector will send a small amount of fuel in here, and that will ignite the spark. That will spark the ignition, and that sends the piston down, and when it comes back up, it pushes the burned gas out of the exhaust valve. So in conclusion, with all these different types of internal combustion piston engines, they have become essential to modernization and development of faster and better vehicles.
The rotary engine is another key part to internal combustion engines. The creation of them innovated how a lot of planes and cars are used today. The functions are quite similar to the piston engine, but there are certain key parts that differentiate the two. The history behind it is that it was originally conceived by a man named Dr. Felix Wankel, which, as some of you might know, or referred to Wankel as the Wankel engine or the Wankel rotary engine. It was inspired by the radial engine in the 1900s during the World War I era. A lot of those planes during that time were using radial engines, but they had a problem because the engine was overheating. The way that it functions is that the engine stays still, but the crankshaft and the propeller were spinning like this, which created the overheating problem. So a way to solve it, they created the rotary engine where everything was just moving as a whole. And that solved that problem. Pretty interesting stuff. The function of the rotary engine is that the main principle of the engine is that it uses the pressure created when a combination of air and fuel is burned, which is of course how a lot of engines are how they function. But the difference is that that pressure is contained in a chamber formed in a housing by a triangular rotor, which is what that engine uses instead of pistons, which makes that difference between the two. As the rotor moves around the chamber of the engine, each of the three volumes of gas alternately expand and contract, which creates that power that makes the rotary engine so awesome. And of course, with every invention, there comes challenges. The rotary engine might run a bit smoother than the piston engine, but there are just problems with it. Not really like technical problems, but just problems in the U.S. in general. One is that it's expensive to make in the U.S. Like the parts that are used to create it are just expensive to have. Two, the U.S. Fuel emission regulations are difficult to follow because that it eats up a lot of gas. So of course that would run into a big problem. So it just goes to show that inventions that are intended to fix one problem will end up having another problem that will arise later on. But the creation of this specific engine has contributed to the progress of internal combustion engines as a whole. While it can be a little more expensive to have and it can eat up more gas, it's still a very effective engine.
I'm Ryan Callahan, and I will be talking to you today about the jet engine. The jet engine is undoubtedly one of the most revolutionary evolutions in aerospace technology. They can come in all shapes and sizes, ranging from the Pratt & Whitney F100, which can take the F-15 Eagle to a maximum speed of 2.5 times the speed of sound, all the way to the GE90, sizing in at over 11 feet in diameter and producing over 123,000 pounds of thrust. A jet engine creates its thrust basically by ingesting flow in the front and then accelerating it out the back. And this is done through the standard internal combustion process of suck, squeeze, bang, and blow. And this essentially means that air is sucked in, squeezed down, ignited with fuel, and then blown out the back. Now this happens in all combustion engines regardless of their type. Now the cycle in a jet engine is accomplished through the use of rotating machinery that operate much like a fan. Now each fan, or disc as we call them, have blades on them that are essentially very similar to wings. These blades draw the flow in deeper into the core. Now the first set of blades that flow meets inside of the core is called the compressor. These compressor blades are lined up one after another and essentially get smaller and smaller and smaller to compress the flow down. Now upon exiting the compressor, the flow will then enter the combustor, where air is mixed with fuel and then ignited. Now this raises the total temperature and pressure of the gas, which is then expelled over another set of blades called the turbine. The turbine extracts all of that energy and uses that energy to run the compressor. It transmits that energy through a shaft which lays in the middle of the engine. The hot gas is then expelled out the nozzle of the aircraft. Now the first implementation of a jet engine was a turbojet. Now this means that the engine has no bypass ratio at all. So basically all of the air enters the core of the engine. And we'll talk about what having a bypass ratio means later. And these engines can be seen on many early aircraft. The first image you'll see is the Me-262, which was one of the first aircraft ever to have a jet engine on it. The B-52 next, and the 737-200. Now, all of these aircraft, you can see similarities in their engine in that they're very narrow and long. Now, today's modern aircraft still do use turbojets. However, they're much more powerful now due to increases in technology, but they're primarily used on fighter aircraft and aircraft that are made to go extremely fast. They're really good at working at high speeds, however they're not very efficient. As you can see in this image, this is an F-16 along with the F-16's engine. You can see that there's almost no bypass ratio, almost all of the flow enters the core. And this propels the F-16 extremely fast. The other type of engine is a turbofan. Now you may have noticed that many airplanes you see today have engines that are extremely large. Companies designing engines for commercial use are all about efficiency now, and new engines are designed with something called a bypass ratio. Now this means that there is a large portion of flow that does not enter the core of the engine. Instead, it travels around the core of the engine. Now this is called a turbofan, and you can see that here, where the fan in the front is much larger than the core of the engine and flow travels around the engine. Now it turns out that with the turbofan, most of our thrust actually comes from that bypass ratio. And this is primarily due to the sheer amount of mass that is passing through that bypass ratio. The bypass ratio also helps reduce engine noise, which allows better operation around populated areas. And we can see some images of aircraft with high bypass ratio engines here. That's the 777, and those actually have the GE90s on them. Next, the C-17. And finally, a 737. Now, up in the corner, you can see a picture of the 737's engine and a cutaway. And what you may notice is that there is a lot of space between the core of the engine and the actual outer cowl of the engine. That's where the bypass ratio exists. Now, in conclusion, jet engines are essential to modern travel. They allow us to travel faster throughout the world, they help us protect our country and move goods and information across the globe quickly and safely. Jet engines are some of the most efficient engines in the world, and they're only getting more and more efficient. Now, I hope you learned a lot from the presentation, and I want to thank you for listening.
Combustion engines have propelled mankind forward and helped shape our modern world, playing important roles in both war and peace, at the forefront of technology and at common man's fingertips. The internal combustion engine powers the vehicle of society onwards and through the road to the future.